This is day 9 of Advent Code, and the challenge is Rope Bridge. This rope bridge creaks as you walk along it. You aren't sure how old it is or whether it can even support your weight. It seems to support the elves just fine, though. The bridge spans a gorge which was carved out by the massive river far below you. You step carefully. As you do, the ropes stretch and twist. You decide to distract yourself by modelling rope physics. Maybe you can even figure out where not to step. Consider a rope with a knot at each end. These knots mark the head and the tail of the rope. If the head moves far enough away from the tail is pulled towards the head. Due to nebulous reasoning involving plank lengths, you should be able to model the positions of the knots on a two-dimensional grid. Then by following the hypothetical series of motions, the puzzle input, for the head, you can determine how the tail will move. Due to the aforementioned plank lengths, the rope must be quite short. In fact, the head and tail must always be touching, diagonally adjacent and even overlapping, both count as touching. If the head is ever 2 steps directly up, down, left or right from the tail must also move 1 step in that direction, so it remains close enough. Otherwise, if the head and tail aren't touching and aren't in the same row or column, the tail always moves 1 step diagonally to keep up. You just need to work out where the tail goes as the head follows a series of motions. Assume the head and the tail both start at the same position, overlapping. For example, R4, U4, L3. Okay, so this series of motions moves the head right 4 steps, then up 4 steps, then left 3 steps, then down 1 step, and so on. After each step, you'll need to update the position of the tail. If the step means the head is no longer adjacent to the tail, visually, these motions occur as follows. So S marks the starting position as a reference point. So head goes to the right 4, 1, 2, 3, 4, and as it moves across, tail is following, and then goes up 4, so 1, 2, and then when it's up to here, when it goes up 1, it's touching, but then when it goes up again, it's now diagonally, so it goes up diagonally to here. Okay, and so on. After simulating the rope, you can count up all of the positions the tail visited at least once. In this diagram, S again marks the starting position, which the tail also visited, and hash marks other positions the tail visited. So there are 13 positions the tail visited at least once. Simulate your complete hypothetical series of motions. How many positions does the tail of the rope visit at least once? So let's grab the puzzle input, copy that, and let's put that into here. So we're going to start off with for each var line in input. So we'll have var instruction equals line dot split space. We'll start off with int x equals 0, int y equals 0. We'll then have var positions equals new hash set string, and we'll also just create a quick little function, string position int x int y. This will return a string of x dot to string comma y dot to string. Oops, forgot curly braces. So in here we'll have position dot add, then we'll do xy. We'll then have if instruction 0 equals u, that will be y plus plus, else if d minus minus, else if l, this will be x minus minus, then r x plus plus. So we need to, so whatever movement this is, this will be x position. Also this will be the head. We then need to figure out the math for how to determine if the distance is too far. Actually, I just realized we'll have a x head, y head, then x tail, y tail, x tail, y tail, and this will be x head, y head, y head. So we need to do math to figure out the differences between x head, y head, and then x tail, y tail. Okay, we'll start off with if x head equals x tail, or y head equals y tail. We will continue. No, that's not correct. If x head equals x tail and y head minus y tail, so you need to figure out how the difference between the two numbers needs to be 1. You know, let's look up just how to do this. Surely there's C# difference between numbers. Okay, there's math.abs, so we can do that. Okay, so this will be y head minus y tail equals 1. And then we put this to here. And this will now be x head minus y head. So if this is true, then it's only just one apart from each other. So the next will be for diagonals. This will just be if this equals 1 and this equals 1, continue. So we've got, if it's just one to the side apart, we've got one diagonal part. This now means the tail needs to move. So to do that, okay, I didn't consider if h covers t. We'll just put another condition here. So if x head equals tail and y head equals y tail, or after ABS equals 1, or that, okay, I think that covers it. So back to this. So what we can do is if x head equals x tail, y tail plus equals x head is greater than x tail, 1, 1, 1, or -1. Then we can do else if x tail equals y tail. Oops, my bad, I did x tail when, and x tail when it should be y. Okay, now this should be the same. So now we need to consider what to do if it's diagonal. Okay, so we can do else if equals 2. Once again, this should be x tail here. We can then do this again. It'll now, okay, I think that's correct. And then next is just doing x. So with these positions changed, we then add it to the position hash list. And then when it runs through all that, we then do console.writeLine position.count. So I have no idea if this is going to work, but let's run it and see. Oh, my bad, it did positions. Whoops, my bad. So let's run that again. Okay, it's giving me 284. Let's see if that's correct. Okay, apparently too low. So as that was wrong, let's grab the sample data and run this, then see what's going on. So let's put the test data in. Now let's rerun it. Okay, well that was wrong. What happened there? Oh, did wrong word there. There we go. Now let's run it. Okay, it's saying 1. Okay, I guess we should console.writeLine and we will print this out. Okay, well that didn't print anything. Okay, the logic error must be here. I guess the better thing to do is go here and see what's going on there. Okay, so I've done a mistake with the input. Oh, my bad. Didn't change the values in here. Okay, now let's rerun this. Guess we should check if that's correct. So start with 0, 0, plus 1, yep. It goes plus 1, then -1. So right, up, left, down. I completely forgot about the numbers. Okay. Yep, we need to change this a lot. Oh no, don't need to change a lot, just need to have all this in a loop. Ah, completely forgot about the number. So focused on the position movement. For int I equals convert.toInt32 instruction 1, I is greater than 0, I plus plus. Now I'll chuck all of this back into there. Okay. Now let's run it. Oh, okay, I need to stop that. Minus minus. There we go. Now let's run it. 10? I don't think that sounds too high. Oh, that doesn't sound correct. 13. Okay, now we'll output the head movements. So 1, 2, 3, 4. That's correct. We will also go down here and print the tail movement. Oops, didn't tail. Okay, let's do this side by side with the movement here. So it's on 0, 0. Head 1, that's fine. Head 2, then 1, 0, that's good. Head 3, 0, 2, 0, 4, 0, yep. So now up 4. So 1, 1, 2, 3, 1. So that did work. 4, 3, 3, 2. No, that didn't work. Oh, it technically did work, but like it still kept the diagonal when I went up. It's just it didn't follow it okay, so I can, if it's a diagonal movement, I can just do the previous one. I don't need to completely do this. I can probably get rid of all this and just have a int prev x head equals x head, then have a previous y head. If it's not side by side, we can do x tail equals prev x head, and then do y y. Let's see if that's correct. Okay, I spelled prev y head wrong. Oh yeah, log it. There we go. Now let's run that. There we go. Okay, so now it's 13. So let's now try this with the actual input. Okay, 6,406. Accidentally kept all the prints in there, so anyway, let's see if this works. There we go. That took forever to do. So, part 1 complete, now let's go on to part 2. A rope snaps. Suddenly the river is getting a lot closer than you remember. The bridge is still there, but some of the ropes that are broke are now whipping toward you as you fall through the air. The ropes are moving too quickly to grab. You only have a few seconds to choose how to arch your body to avoid being hit. Fortunately, your simulation can be extended to support longer ropes. Rather than 2 knots, you must now simulate a rope consisting of 10 knots. 1 knot is still the head of the rope and moves according to the series of motions. Each knot further down the rope follows the knot in front of it, using the same rules as before. Using the same series of motions as the above example, but with the knots marked H1 to 9, the motion now occurs as follows. Okay, interesting. So it's now based on each of them. Okay. Yeah, that makes sense. Okay, so let's copy everything in part 1 and bring it to part 2. So we can't just have y tail like this. We'll just do a new int of 9, and same thing here. So when this occurs, we need to go through here. We'll get rid of the prints. So it'll essentially be the same as before, but we'll now do for int I equals 0, I is less than 9, I plus plus. So it changes to previous x, previous y. We'll have if I equals 0, we'll do everything based off of that. So this will be y, x tails, y tails. For the beginning, we'll just do this. Okay, no, we don't need to do anything like that. So we'll have prev x, previous y. This needs to change to prev x, prev y, x tails I, y tails I. Then we'll add these numbers into here. But we also need to record these numbers. Int temp x equals xi, temp y equals y tails. And then when this is done, prev x equals temp x, temp y, prev y equals temp y. So we'll go through like that. We'll move like normal. Okay, we need to change all these values still. So wherever it's head, we need to change with previous x, and wherever it's y head, change with previous y. Is there anything? Oh yeah, and then we will do int x tail equals this, int y tail equals this. I think that's all we need to do. Let's run it and see if it works. Okay, I have local parameter I cannot be declared. Ah, my bad. Already using I here. We will do name this tail. Now let's run it. My bad, I forgot to change this here. So now let's run it. Okay, what error is this? Index was outside the bounds of array. Line 10. Okay, this one we will change. Yep, forgot to do I, so tail, tail. Now let's rerun that. Okay, apparently 7,266. Let's see if that's correct. That's not right. Answer is too high. Make sure you're using full input data. Okay. Let's go back to test input and see what that looks like. So it says 20. So it's meant to be 9, but I got 20. I might just need to change this. I don't think this will do anything, but I just want to see if it does make any difference. Okay, my bad. Don't need these. Now let's give it a shot. Okay, same number. Not sure where I'm going wrong. Let's try the other test data that we were given, which is this. Need to put the test data here now. Okay, got 46. but it only visits 36. Oh, we only need to keep track of the 9th one. Ah, if I actually read the instructions, we would have finished this way earlier. If I equals 8, then we will do this. Oops. If tail equals 8. Okay, 3783. Let's put that in and see if it's correct. Still too high. Okay, let's go back to that test data and let's look at the movements of the tail. If it goes up 8, so it's currently here, it goes 1, 2, 3, 4, 5. I think the original code I had, which I apparently deleted. Okay, I'm gonna undo it all and try to find that code. Okay, we're back here, so I think this code might fix it based on how the tail moves. So we've got the temp. I have no idea if this is going to work. I'm kind of guessing at this point. Let's do the test input first. Okay, well that definitely didn't work. Okay, I'm just going to undo this. Going to give a random shot here. So if tail equals 0, 0, do that. No, that won't work. I don't understand what's wrong. Okay, I'm starting to think that the logic I have is completely wrong, and I got lucky that the first one's right. I shouldn't be comparing with the previous one, I should be comparing it with the current one. Oh no. I've been wasting so much time and it's because I did it wrong. Oh no. Okay, I think that might be it. So if it's the first index using the head's values, otherwise you're looking at the previous tail. So let's run that and see if it works. Okay, it's still error. If tail does not equal 0. Let's give that a go. 80? This is the test one, it shouldn't be 80. Oh, that should be continue, not break. I'm hoping that is why that failed then. Let's go. No, that's still 80. No, we don't need this anymore, do we? Don't need the previous, we just need the x compare here now. No, that's not right. Because we're saving the value that it was before it changed. See if that changes anything. No. Okay, so after such a long amount of time trying to figure out where I went wrong, I think I've actually got it now. So before I had else if mathrabs like equals 2, I had 2 separate ones, but what I didn't consider is if x equals x, then you go on the y-axis. If y equals y, you go on the x-axis, and then else if none of them are equal, it's going to be a diagonal. So the diagonal is now based on the previous one. So I've spent so long on this. Now let's actually try it with the proper input. Oh yeah, then I also removed all the previous stuff because that was causing issues. For some reason I was doing it so you got 1 point here, 1 point here. If this one moved, or was it wherever it moved, it was doing the comparison based on where it was previously, but it's actually here now. So that was one mistake I did. Okay. Let's run the actual input and see how we go. Okay, 2,643. Let's submit that. We finally did it. It took me 1 hour and 44 minutes to figure this out. So I'm going to have lots of fun editing this video. Good luck to me. And, well, if you like this video, make sure to like and subscribe.